Firstly, I'd like to welcome all of you. Thank you for taking the time to come and listen to us, and I'd like to thank Professor Ayşegül for these clarifications that she made. So this session actually is a debate. In this debate, we are going to compare classical meta-analysis and the relatively new network meta-analysis, and we will see the differences, advantages and disadvantages pertaining the two. I will talk about classical meta-analysis. Regarding this, I will try to show the advantages and disadvantages. At this point, when we make such a comparison, we should not forget the following. These two are not completely alternatives to one another. We have a certain situation. When assessing the situation, we should decide whether or not we should opt for meta-analysis, standard meta-analysis, or network meta-analysis. We can have different reasons for choosing one of them, but at a given point, when making a decision, we should choose one of them. Standard meta-analysis or classical meta-analysis, when choosing this option, we do the following. Let's say we have a new drug that has been used for a while, whose random studies have been completed. So we want to see the efficacy level of this medication. We want to see whether this drug is better or not than the other drugs. So we are looking at the studies done for this drug especially, and we are combining all these studies. This is the classical meta-analysis. It's a dual analysis. We compare a drug with placebo or a drug with another one. So this is the classical meta-analysis in which we compare two drugs. Most of the cases it's not sufficient because these comparisons should be more comprehensive for many cases, and more drugs have to be compared, and in these studies we need to see more results, more comparisons, not only with placebo but between different drugs. So as we have heard from Professor Ayşegül, if we want to combine all these studies, we have to opt for a network meta-analysis. Classical meta-analysis, it's explanatory on its own. It's classical, it's being used over time, it was able to survive, it's still used. This is how we make a decision whether or not this drug is still good. Let's see the advantages of classical meta-analysis. This is the plan of my presentation. I will first explain what meta-analysis is. I will talk about the reasons why we need meta-analysis. We'll see systematic compilations, dual meta-analysis, network meta-analysis, the steps of meta-analysis, advantages and disadvantages pertaining to this, and we will continue with that. First of all, let's explain. Meta-analysis brings together many studies testing the same assumption. Meta-analysis, it's not a test for hypothesis. The statistical difference between the comparison is not what is meant here. When we bring together many studies that were done up to today, we see the risk difference or the efficacy difference after this analysis. We want to see the efficacy level. This is the method that we use in order to see that. So this is the history of meta-analysis, for classical meta-analysis. One of the interesting things here is that they go back until 1904. Carl Pearson started the application of vaccination for mortality studies, and it evaluated the lack of responses. So although it seems like a new approach, it goes back to 1904. Also, this is the beginning of the 20th century. This is where statistics became very popular. There were two important names. One of them was Pearson and the other was Fisher. I'm sure you've heard of all of them. These two were kind of competing with one another. Pearson was the editor of Biomedica journal. And also, between these publications, there was some conflict, and that's why he was able to see the difference between different publications. The reason of the enmity between the two, Fisher published a publication, a research. Fisher is known to be the father of statistics. He's referred to as the father of statistics. So Fisher made this publication, and Pearson was very critical of this publication and had his students recalculate all these statistics, and Fisher then dedicated his life to counter-prove all the theories by Pearson. So that's one of the reasons why we did not have any more theories. This is the maltreatment of Pearson towards Fisher. So do not forget that when you write articles. This is one of the reasons why we don't have more theories today. Pearson was caught in between all these criticisms, and he thought about meta-analysis back in 1904. And then later in 1931, Tippett made a non-medical research and used meta-analysis. Later, Cochrane made a different compilation of different medical treatments in order to compare their efficacy levels. This is the first study on a meta-analysis of different studies. And in 1980s, computers came into picture. With this development, we had wider databases. It was possible to distribute articles more widely. That's facilitated and changed the destiny of meta-analysis. And with this development, meta-analysis became widely utilized. So this is the history for classical meta-analysis. Why do we need meta-analysis? Why do we need them? That's the reason why we need them. Because there's lots of data. There's all these studies around. This picture is from Neuroscience Conference. This is the poster presentation of Neuroscience Conference. I'm sure many of our colleagues have been in similar presentation environments. The lesson to draw from here is that we need to have a wider area for poster presentations because they have enough space to walk around, and this is really large. So every year this much of publications and research are being done. So now the contribution of single studies is really small to science. So instead of having individual studies, it's better to compile different studies. It's better to try and create a wider contribution to science. We need to have bigger studies in order to reach that goal. So we need to ask the following question. Should we use the time to come up with more data, or should we use our time to make more analysis? So I'm sure our colleagues working on databases would know better. For example, in genetics, NIH has a data server called TPCAP on which you're able to see the information pertaining to 3,000 patients. You can download the results of these studies. 300 gigabytes of information is available for your use, and you can analyze all this data. So you have numerous open resources on which you can share data and analyze. Is it more advantageous to work on this source of information, or is it better to gather new information or new data? If you make the proper analysis, it's much more efficient. For example, one of the guests of last year's conference, I was the moderator in that session. I checked his publications, and I've seen that he had 1,000 meta-analysis. So data collection, making research. A good meta-analysis can sometimes replace new research. So let me give you brief terminology. Compilation we decided to make this following description. Of course, we should continue to come up with new data, but if we have a unique idea, in line with this new idea, we can use already existing results of studies, and we should come up with new suggestions. Of course, we can make new compilations. It's not course notes, of course. Sometimes it's misunderstood as the compilation of course or lecture notes. But we should gather information from first studies about this subject, or most important studies about this subject. These are called qualitative compilations. There is also systematic compilation, in which you refer to Cochrane databases. These are systematic compilations. It's gathering different studies on a given topic based on different criteria. You can reach this information, refine them, filter them, and use the findings to make a presentation. This is called systematic compilation. If you provide numbers with it, then it is quantitative compilation. We gather data, we talk about the findings, but we are not getting a new value, a new result out of these studies. We sometimes make comments like those who used this data found that ciprofloxacin was more advantageous, but we are not calculating a new measurement or a new number. In meta-analysis we do. In meta-analysis there's two options, two approaches. The first one is to make use of direct raw data. But of course everyone wants that. Not everybody is willing to share their findings. Therefore, the second option comes into picture. This is the gathering of processed data. The raw data is difficult to obtain, and it's also difficult to gather those because everybody is focusing on their own studies and they have different methods of presenting it in different databases. It's different to compile these. Therefore, when it comes to processed data, it's relatively less risky in terms of making mistakes, and therefore the possibility of finding new outcomes is higher. This is Cochrane database. Method quality and clinical methods are analyzed together. This is a sample of meta-analysis. It's compiling quantitatively previous findings. This is the network meta-analysis, as the previous speaker showed. Because it's a debated issue, we are showing the article of Cipriani again. It's showing the comparison between more than one drugs and making comparison between them. These are the steps needed to make meta-analysis. First of all, we have to describe our problem. Then we need to define the criteria to include in this study. We have to gather the studies to be collected. Then we have to revise each and every study. Up until the third point, actually, we can discuss the third point as well. Up until the third point, this is common with meta-analysis and network analysis, but in network analysis, we will see in further detail. For example, in the compilation of studies, in meta-analysis, this is becoming more difficult. Revise the methods and tools of each and every study. It's also getting more and more difficult to do that. Standardize the results of each and every study. Carry out statistical analysis. Statistical analysis might not be the proper terminology to use. Maybe modeling would be the proper term to use here. Because in network meta-analysis, as per the requirements of these studies, there are already proven findings. Also, based on these findings, it's possible to come up with new methods. Some methods are utilized, some methods to forecast new results are utilized in order to do that. These are not statistical calculations, these are rather modeling efforts. And then later, we have to evaluate the variation between different studies. Organize findings, interpret them, and publish them. These are the steps. There is a kind of a hierarchical listing between different evidences. If we have a high-quality meta-analysis, randomized controlled experiments and systematic combinations are the subject here. Therefore, we have a high level of evidence. Evidence hierarchy, when you look at the pyramid for these hierarchical relations, you see that it starts with expert opinion and it goes up to more comprehensive studies. It goes up to randomized control studies and their meta-analysis. If you look at the next phase, that's the second step, you see the following. In year 2000, there was another step which was added on top of that. We said that we had too many publications, too many studies. So we started compiling them in meta-analysis. Of course, then we started to have a lot of meta-analysis. Now we have different phases of evidences. If there's more than one meta-analysis using the same evidence, then these phases are becoming more numerous. Advantages and disadvantages of meta-analysis. This can be applied to a clinical research question. It's the systematic research on clinical findings. There's a certain selection criteria for resources and evidences. Primary studies and their internal relativities are being assessed. In classical meta-analysis, subgroups can be compared. And disadvantages, shortcomings. There could be loss of effort because of non-suitable results. Sometimes we carry out the comparison, but we cannot come up with the results, with proper results, therefore the effort would be lost. Sometimes there's conflict of interest. For a given study, in network analysis, can you compare them with network analysis? This is the last 8 minutes. I think I will finish in 8 minutes. Conflicts of interest is one of the disadvantages. There are some studies that we cannot access. Okay, let's continue with the following. Some studies cannot be reached. For example, the classical meta-analysis compared to network meta-analysis is much more advantageous because you are more focused for your target. The more focused you are, the better the less unreached studies you will have. Internal consistency is higher in meta-analysis. The first studies on a given subject are always directing the following studies. If there is a previous study based on risk, then the following studies will focus on the same criteria. So the correctness of the first study will be determining. Therefore, following studies usually are similar to the initial studies in a certain area. So meta-analysis bring together these different studies, therefore they will have more problems. For heterogeneous studies and gathering them, in that case classical meta-analysis is more advantageous. Some studies are not compatible with the novel methods. But this risk is less in classical meta-analysis. This is the dual meta-analysis comparison. For network meta-analysis, the criteria that we are interested in is the efficacy of the treatment and heterogeneity between different studies. We have the dimension and heterogeneity issues here. To what extent is the treatment efficient, and to what extent are they heterogeneous? In dual analysis, heterogeneity is lower, and standard deviation calculation is higher. This is the forest plot of a classical meta-analysis. When we call something measurement, we mean the combination of the real situation plus a certain margin of mistake or error. And this is the result of our measurement. Did we add the factor of confusing factors? If we are making standard meta-analysis, all these factors are important in terms of the relations between the reasons and the results of them. When we analyze their effect, we see the effects of all the factors on this result and also the interaction between different results. So it becomes more complex. Therefore, the number and the effect of the confusing factors are becoming higher and higher. In network meta-analysis, we tend to experience the following problems more often. We might want to see the evidence interrelated to one another. It's highly probable to be more successful to define the best treatment alternative. There could be inconsistencies between potential problems, and the indirect evidence could replace the direct evidence. As you're working on models, you would know better. The assumptions that you provide at the beginning might have a potential to affect the result. For example, we will have a course today. At the beginning, you will have some assumptions, you will have some criteria to measure. Variable A might be the biggest effect on the result, but if you add up one more variable, then variable B will have a bigger effect on the result. So the context and the scope of your first assumptions will have a direct impact on the results. These are examples from different articles. It's stating the following. Is network meta-analysis as valid as standard pairwise meta-analysis? And it also says that it all depends on the distribution of effect modifiers. This is a summary that I wanted to draw. If we believe that these variables will have an impact on the result in a standard meta-analysis, when defining these variables, we make assumptions. For example, we say that drug A will have a certain effect on depression. When we assess this evaluation, we will have confusing factors like age and sex, and also previous utilization of other drugs. So this is the restriction that we bring. In dual meta-analysis, these confusing factors will be taken into account. We will select those articles who do that. Then you become more strict. But you will have to think of different effect modifiers in standard meta-analysis. Therefore, you could have more problems in indirect assumptions. Network meta-analysis is more sophisticated, could create wrong interpretations. And therefore, you need to include the effect of effect modifiers in your result. Consistency or inconsistency of network meta-analysis. Their weakness is the following. They have a circular inconsistency. That means if you have an inconsistency that you have already included in your system, then later on it will become more difficult to forecast other criteria. Therefore, it will be recurrent, it will have a bigger impact on your design and will create higher inconsistency. It will be riskier for your study. And also for network meta-analysis, it's a recent study that says that network meta-analysis are beneficial. However, we need more studies. And that's the last article that I want to mention, Cipriani's article. That's the review and that's the meta-analysis. This was published in the Lancet. I have learned a lot from this publication. One of the things that I've learned was the following. This is the network. We wrote also an article about this. I had seen an article. Wrong findings are referred more often than the correct findings. sometimes if there is a wrong assumption, it's impossible to prove the contrary. When Cipriani wrote this article, it was sensational. Everybody wrote counter-proving articles, or they said that he was wrong. And for example, they asked whether all antidepressants were the same. There's this meta-analysis, assuming that all antidepressants are the same. It was a publication in the Lancet magazine. It was referred to 12 times more than any other article in the Lancet. So this is the difference that we have between the right and wrong assumptions. So what I've learned from this article was the following. When we were looking at the biases, this is not an argument. This is not the argument that we should be discussing, but we should discuss the writer of this argument. This is ad hominem. Unfortunately, in many articles, we refer to Cipriani. He's a psychologist and not a psychiatrist. Therefore, it's wrong for him to make assumptions regarding treatment. This is a bias. This is independent from network analysis. About the future of network meta-analysis, I'm almost finished. Network meta-analysis can compare many drugs at the same time. In fact, this is not all that we want. We want to compare, of course, many drugs, but also we want to have many layers, including different levels, treatment effect, treatment size, and time effect. For time network analysis, I think we need to start doing that. Time aspect of meta-analysis is very important. Again, going back to the previous article, I have learned that I'm being biased. For new drugs, especially for psychiatric drugs, every new antidepressant starts with high levels of efficacy. And then later, they start with high levels of efficacies, but then later, as time goes by, the efficacy levels goes back to 1.2 or 1.3. This is the new drug effect. In meta-analysis, there's this kind of problem. When we make dual comparisons, always new drugs start with bigger advantages compared to the existing drugs. This is my last slide. I like this quote. The great advances in science usually result from new tools rather than from new doctrines. So classical approaches will always be around, but we will always keep having new approaches. Thank you very much.